if you need to look at it again, you can play around. So again, let's say that again. When you take two integers and you divide them by each other in Ruby, you will always, always, always get an integer. So 8 divided by 4 will give you 2, and 9 divided by 4 will give you 2 as well. Be careful. That's a source of mistakes so easily, because it's not the way you think about it in math. Right? Yes, Blake?
Why is it that when you put 7.0 divided by 2.0, you actually get 3.5?
Aha. So Blake has already figured out the answer on how you get around that problem. So far, all we have dealt with are integers, right? But there's got to be a way to enter non-integers inside of a computer. And obviously, if you use a decimal point, then Ruby implicitly understands that it's not an integer. So let's do this. I'm going to do something similar, but not exactly what you did, Blake. I'm going to say 7.0. Oops, I'm no longer here. Hold on. 7.0 divided by 2. Not 2.0, just by 2. And what will it say? It says 3.5. So what Ruby does, it says, wait a minute. You're giving me an integer and you're giving me what's called a float, or a decimal point. And we'll refer to them as floats. And it says, well, let's be smart. If the boss, the user, is giving you a float and an integer, they probably want the answer to be with the decimal point. They don't both have to be, as long as one of them is. Does that make sense? So you should be able to infer from that if I do 7 divided by 2.0, you get 3.5 as well. It doesn't matter if it's the 7 or the 2. That matters that one of them is a float. And as Blake suggested, if you do both, then you will get the same idea. 7.0 divided, that's float by float. So integer divided by integer will give you an integer. And then whether you have an integer or a float divided by a float or an integer, as long as one of them is a float, you will get a float. This is like one of the trickiest things about Ruby you will have to master. I mean, if you already understand it, you're already in great shape. 6s all around. That's what we're talking about. Questions? We doing good? Doing well? Okay. So, 4 operators, plus, minus, multiply, divide. We already dealt with the type, the kind of nastiness of division. What other operators would you like? So what's that?
Percent.
Next, after.
Square roots.
Ooh, even harder. No. It turns out square roots are not easy. There is a library called the math library to do things like square roots. Okay? Basic operators, actually, the one I'm thinking about that is built in is exponential. Okay? Just raise things to an exponent. Now, what might you think is the symbol for an exponent? Okay? Most people, I thought, would guess that it was the little thing like this. And that would be incorrect, unfortunately, even though that's fairly intuitive. The answer is 2 stars. That's how you do it. In fact, let's take a look at it. If I were to say 2 star star 4, I should get, okay. If I do this, that pretty much sucks if you're going to do that, right? We may talk at some point about what that little tilde is, but it's a very advanced, actually, arithmetic command that you have never encountered in your math classes, and you will not encounter in this class. If you go further, actually, when we study binary numbers around midterm, maybe we might need to go back to this, and it has to do with binary numbers, and we can revisit it at that point. But the key you want to remember is that exponential, to raise something to an exponent, it's a double star. That's it. Can you do big numbers? Will the computer get tired? I don't think so. Yeah, you can do big calculations. All right? Okay. We've got 5 more minutes. We are right on. So we have one more thing that we want to learn. There's one more operator. So we have 5 so far, right? One more, 6 basic operator, which Jack referred to already, being the percent. So the percent is an operator that at first does not feel very intuitive or useful, and then as you learn it, I think you're going to start warming up to it. It's very useful. Let's experiment with it and let's just see what happens. Let's say that we do this. We're going to do 7. I wish, hang on 1 second. No. Okay. Let's do 7% 3. Hmm. 7% 3 is 1. Clear as mud, right? You already, unless you already know what it does, can you guess what it does? Did you know, or did you just cheat? Sort of. Okay, let's try a couple of those again, and let's see if we ever can start a pattern. If I divide 7 by 3, what will be the remainder? Right? If you divide 7 by 2, what will be the remainder? 1. What if you divide 7 by 7? What would you expect the remainder to be? Okay? What if you divide 7 by 1? 0. What about is 7 modulo? This is the name of this. It's called modulo. Why do you think this didn't work? Is it divided by 0? So the way it works is that it takes the parameter on the left, the 7, and it divides by the one on the right, and it doesn't care about the quotient, it just gives you the remainder. So here I was attempting to divide 7 by 0, and it crapped out. So not super useful necessarily right off the bat, but you will see that there are some very specific usages for that actually will come in very handy. One of them, by the way, is odd and even. How do you know if a number is odd or even? Well, you do modulo 2, so you're dividing by 2, and your remainder is one of 2 things, right? It's either 0 if you have an even number, or it's 1 if it's an odd number, right? That's one of the usual applications of that. So, can this work then with floats? Can you do modulo with floats? No, it works. So if I do 7.5 modulo 2.5, what would you expect the answer to be? Right? 3 times 2.5, not taxing you too much arithmetically so far? 7.5, you guys okay with this? Yeah, gives me a 0. Oh, notice one thing. Not just 0, 0.0. Again, Ruby says, these are not integers, these are floats. Let's deal with floats. Okay? But what if you do something a little weird, like this? And this is pretty much one of the last things we'll do today. You feeling good about this?
What does it say, 7 point?
Sorry, I wish I could make this, I don't know why I can't make the screen bigger, I'll have to figure it out for tomorrow. 7.5 modulo 2.1. Okay, so let's do the math. How many times does 2.1 go into 7.5? 3. 3 times 2.1. Somebody's looking through the window right now. They're going to wonder what kind of math class you're in, right? Come on, children. 3 times 2.1 is 6.3, right? So what's the remainder? 0.2. Did I lose you somewhere along the 7.5 way? 1.2, right? What did Ruby say?
1.9.
Hey, that sucks. Okay? This is not a big deal. I just want you to tuck it in the corner of your mind right now. Floats are not exact numbers, right? You can think of floats with decimal points that go all the way. Ruby is not smart. It doesn't go, well, it has to be 1.2. It approximates. He goes, well, that's the best answer I got. And it will be your job to make sure that you format it in the way you want. Maybe you want the result to be like this. Maybe you don't want the result to be like this. Because that kind of looks a little bit weird, right? So just tuck that in the corner of your mind. Floats, there's always this issue of how much precision you want to get on your float. All right, so today, you're up on cloud 9. We talk about basic arithmetic, 5, 6 operators really, the 4 basic ones, exponential, modulo, integers, integer to integer is integer. If you put a float somewhere in the mix, you get a float. That's it, that's the rule, right? And that's it. So, for tomorrow, does the bell no longer ring?
Today is Thursday.
Oh, it's
but
Thursday.
But it's a Friday schedule.
Okay. Yeah, but not as far as the bell is concerned.
It's confused today.
It's confusing. We have class tomorrow, 2 p.m. Be there, aloha. Right? You have homework for tomorrow. It should not be overly taxing. You should just have a little bit of reading to do, which is going to reinforce what we talked about today. I think there might be a couple little problems. If you want to just hang out for the sake of it, I'll be here between 7 and 8. I'm not going anywhere. All right? Have a good day. See you tomorrow. So Blake, make sure, let me know, I'll do tomorrow morning, but hopefully you'll slip this process for tomorrow. If not, then you'll have to go talk to somebody in GW about that.
Sorry, I was late today because I was in Ralphville.
You were where?
In the chapel for Ralphville and I stayed.
No worries.
That was fun, Mr. Hugon. Thank you.
Thank you, Mr. Scott. Bye, guys. See you tomorrow.